From the creators of Toy Story, Walt Disney presents a Bug's Life themed presentation on the quadratic formula and the discriminant. Bet you thought I was going to say we're going to watch the Bug's Life, didn't you? Well, this is section 6 of chapter 9. And so far we've learned a lot about quadratics and different ways to solve quadratic functions. And we've learned the graphing method, square roots method, factoring method, completing the square, and now we're going to learn the quadratic formula. The quadratic formula is something that will always work to solve a quadratic. It may not always be the easiest, but it will always work. So here's our two objectives that go along with this lesson. To solve quadratic equations using the quadratic formula, that's the first part. And the second part kind of goes off of that, and that has to do with finding the number of solutions of a quadratic equation. So if you're given a quadratic equation, you can use part of the quadratic formula, called the discriminant, to just determine right away if there's going to be one solution, two solutions, or no solution. It especially helps if there's going to be no solution, then you don't have to go through all the work. So we've got two things here for kind of vocabulary. The quadratic formula, which we've worked with, or sorry, the quadratic formula says, or we have not worked with this, but it says if ax squared plus bx plus c equals 0, so there's your quadratic function, and a is not 0, then x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Seems like a lot right now, doesn't it? But it's really just a formula where you can plug in the a, b, and c to find our x or x values. All right? Part of the discriminant is the portion of the quadratic formula found under the radical symbol. In other words, it is the b squared minus 4ac. Okay? The value of the discriminant determines the number of solutions there's going to be. And if you want to take a look and pause this kind of shows why it works, where the formula comes from, but we're not going to focus a lot of time on that. We just want to make sure we know how to use it. So, using the quadratic formula. The quadratic formula can have two, one, or no real number solutions, and you'll find that out once you solve it. A quadratic equation can never have more than two solutions, though. If you think of the graph of a parabola, it'll never cross the x-axis more than twice, if it is a true parabola, if it is a quadratic equation. All right, so here's an example. It says solve 15x squared minus 8x equals 4 by using the quadratic formula. So first of all, step 1, and we're going to do this example along with the steps. Step 1, put the terms in descending order on one side of the equation. So we have to have 0 on the other side of the equation. All right? So oh, sorry, this is being weird. All right. Here we go. All right. So that we have it set equal to 0. Now identify your a, b, and c values. So a would be 15, b would be negative 8, and then c would be negative 4. Substitute a, b, and c in for the quadratic formula and solve. So we have minus b, so that'd be minus a negative 8, which is going to turn out to be a positive 8, plus or minus the square root of b squared, so that's negative 8 squared, minus 4 times a times c, all divided by 2a. So we have it all plugged in there. And what we can do right now is start simplifying. This part right here is going to be a plus, so we have positive 8. The bottom, definitely we can do, is going to be 30, and inside of here, 4 times 15 times negative 4 is negative 240. All right? And then when we have minus negative 240, that becomes a plus. So now we're left with 8 plus or minus the square root of 304, all divided by 30. And the plus or minus is where we get multiple solutions from, because we have to do the square root of 304, which ends up being 17.4-ish. Okay? So we're rounding here, but that's okay. So we have, then that's where we break it off. When we have 8 plus or minus 17.4 over this over 30. It's where we break it apart into two different equations. We have 8 plus 17.4 divided by 30 and 8 minus. The plus or minus now becomes two different equations because you get two different results when you simplify it. Because 8 plus 17.4 is 25.4, and you divide it by 30, you get 0.8. And 8 minus 17.4, all divided by 30, you end up getting negative 0.3. So there's our two solutions. They're not pretty in this one, but using that quadratic formula, you're just plugging in A, B, and C and solving. It's a formula. Formulas are great. This one's a little bit messy and hard to remember, but it's great if you can plug it in and use it. So here's what I like you to do is to try one on your own. Pause it and find the solutions of x squared minus 4x equals 21 using the quadratic formula. So why don't you pause it, and then what you can do is check it after you're done working on it. You can press play. All right, so when you solve it, you plug in for a, b, and c, and you get minus negative 4, plus or minus the square root of negative 4 squared, minus 4 times a, which is 1, times c, which is negative 21, all divided by 2 times 1. So I simplified a few things. I ended up getting 4 plus 10 divided by 2, or 4 minus 10 divided by 2. And those two results give me 7 and negative 3 as our two solutions, right? So that's using that formula. That one worked out nicely. Now, here's a real-world example just to throw in there to show when you're finding approximate solutions. And that's kind of what we did with that first one, too, because we approximated, we rounded. But it says, in the shot put, an athlete throws a heavy metal ball through the air. The arc of the ball can be modeled by the equation y equals negative 0.04x squared plus 0.84x plus 2, where x is the horizontal distance in meters from the athlete, and y is the height in meters of the ball. How far from the athlete will the ball land? So that would be, we want to find the x. So we're going to try to solve for x. And so what we want to put in for y is 0, because we want it to be 0 height where it's at the ground. So we want to plug in 0 here for y. Okay? And we do that, and we have our quadratic equation. We can plug in for the quadratic formula, and we get two results. We end up getting x is negative 2.16, and x is 21 or 23.16. And remember, think about this real life situation. Could the ball be a negative distance away? Now you might say he threw it backwards, but we're going to assume he threw it forwards. So we can't use this one, and he threw it 23.16 meters. All right. So that would be our result, approximating. Okay. I would make sure you have that written down, or use this new one, but we're not going to go through this new one at this time. What I want to get to next is this part right here, using that discriminant. So the discriminant is part of the quadratic formula because we just talked about the quadratic formula, so I want to talk about this quick. The discriminant is the part underneath the square root. So it says quadratic equations can have two, one, or no real number solutions. Before you solve a quadratic equation, you can determine how many real number solutions it has by using the discriminant. The discriminant is the expression under the radical sign in the quadratic formula. So here's how it works. If you plug in for b, a, and c for this part, so we're just saying b squared minus 4ac. And if you get a negative result from just that part, if you think about it, that doesn't make any sense. You can't take the square root of a negative number, because you can't get a number times itself to equal a negative number. So that would mean that there's no solutions. If you end up getting 0 under there, the square root of 0 is just 0. You're not going to get, that's not going to change. It's like this whole part would be going away. So there's going to be only one solution then. The plus or minus doesn't really have a factor then. And then finally, if like the ones we did already, if you get a positive number there, you're going to have two solutions. So that's kind of what is right here. I'm showing this in this chart. If you'd like to write on this chart, this is a great thing to write down. It's a great way to check. If you have a negative discriminant, like I just said, a negative discriminant, when you solve here, if you look at this quadratic formula, and you get negative 23, there's no way you can take the square root of it, so there's no real roots. And it would be a graph like this. It's not that it's not possible. There's just going to be no x values that where it would cross the x-axis. So it's going to be a parabola that's either above or below the x-axis. So there's real roots or x values for that one. If you get zero, if you get a zero discriminant, like here, where you have the square root of zero, that's just zero, so that's not going to affect it. There is the same, so there's just only one root here. It's only going to touch the x-axis. And then finally, a normal one where you have two real roots would be a positive discriminant, and that's where it would cross twice on the x-axis. Okay? So here's an example of that. So state the value of discriminant for each equation, then determine the real number roots of the equation. So we have x squared plus 3x minus 4 equals 0. So we have our a is 1, our b is 3, and our c is negative 4. Right there. Plugging that in, we can look at this discriminant right away. So if we plug in for the discriminant, we'd have 3 squared minus 4 times 1 times negative 4. Alright, and that would be 9. Minus a negative is going to be plus, so it's going to be plus 16, which is 25. So we have a positive one, so it's going to be 2 real roots if we look back at our chart. There are going to be 2 normal results. So I got 25 right here like we just did. So when you take the square root of that, you are going to do plus or minus 5 in that formula, and you'll have 2 real roots. So why don't you try this one on your own. Pause it right now. I'll work it through. You work it through, and we'll see if we get the same answer. So when I completed this one, I ended up getting, you can see my work here. Make sure you subtract 7 from both sides so you get the minus 7 there, and you have a negative c value. But when you use a discriminant, you get 193, I believe, if you do it correctly. And that means it's a positive. So if you look at the chart up there, positive said you'd have 2 solutions. So it'll cross the x-axis twice. So that's how you can use that discriminant. What I want to do last is talk about, real briefly, we have, if you look at this chart, this is another great chart to write down, because sometimes you might be just given a quadratic function and you want to find the best way to do it. There's different ways you can do it for most of them, but finding the best way would make your life easier. So if you to use the graphing method, it's easiest if you have a graphing calculator, because it takes a lot of work to graph. It'll always work, but sometimes you'll have to estimate. Using square roots. Square roots sometimes work, but it has to have no x term, meaning it'd have to be ax squared plus c equals 0. So no x term. Factoring. Factoring works a lot of times too if you can factor the equation easily. Now you should be able to factor most equations, so it should almost always work, but it might not always be the easiest. Completing the square should always work, but I would say use if the coefficient of x is 1. It's not easily, but you cannot easily factor the equation, okay? And then finally, the quadratic function that we just talked about, quadratic formula, always works again. And I would say, again, use it if you cannot be easily factored or at all. Because, again, factoring is probably the easiest way. If you can factor the quadratic, use factoring. All right. So just real quick, I have 3 of them to finish off with, and I want you to think about and decide which ways do you think would be the easiest for each of these. I'll do number 1 with you, and you can do the next 2. So looking at number 1, we have x squared minus bx plus c equals 0. I'm going to say right now, I'm going to factor. Multiply to equal 12, add to equal negative 8. It's going to be x minus 2 and x minus 6. So I'm going to say factoring here. It'll work. And then I can already do that in my head. The real roots are going to be 2 and 6. So I'm going to have you try the last 2. So I'm going to pause it real quick. Why don't you pause it and try to figure out what would be easiest for the last. All right, so we said factoring for the first one. Now, obviously, the quadratic formula would also work. Um, Potentially completing the square would work, but factoring is going to be the easiest. Second one, we have, if we write this in descending order, we would end up having, um, oh, I need my pen here. We would end up having 169x squared minus 36 equals 0. Now, if you look at this, there's no x value. There's no x term. There's no middle term. There's no b term, I guess. So when there's no b term, square roots might be the easiest way to do it, using square roots. I mean, you can always use the quadratic formula again. Square roots might be the easiest in this case. And the last one, 5x squared plus 13x minus 1 equals 0. I would not use completing the square, because there's a coefficient in front. You could probably factor it. It might not be the easiest. I would say factoring would be a way to do it, or the quadratic formula for this one as well. Those would be my top ones for this one. Let's see what I end up having under here. Quadratic formula. Oh, and graphing, I guess, if you have a graphing calculator. All right. So again, deciding what the best one would make life easier on you. So we're going to end up with going back here to our original goals, our learning targets, our objectives for today in section 6 of chapter 9. To solve quadratic equations using the quadratic formula. I think we did that. And to find the number of real solutions of a quadratic equation. And I think we did that using the discriminant. We even added talking about the different ways that we've learned so far to solve a quadratic and finding the best one. All right, so that's the end of our Bug's Life tale of the quadratic formula. So we'll see you next time. I hope you got something out of this one for solving quadratic functions. See ya.